Hi everyone. This is our first look at stereochemistry. Stereochemistry is going to pull together our work with individual Lewis diagrams as well as Lewis diagrams for molecules, including our work on multiple bonds, and pull all of that together and then take it up a notch. Stereochemistry is about thinking about and even drawing molecules in 3 dimensions. To do that, we're going to focus on what we call central atoms. The tricky thing about it is a molecule might have more than one central atom. In the beginning, there's only going to be one central atom, but as we move forward pretty quickly, we're going to encounter sometimes 2 central atoms, and every once in a while, even 3. Any atom that's bonded to 2 others is a central atom. If there's an atom and it's bonded to 2 others, if it's between something, counts as central. We're going to analyze central atoms. Every central atom we're going to analyze for a couple of different things. Lone pairs. Lone pairs come from the Lewis diagrams, from individual atomic Lewis diagrams, or from a correct Lewis diagram of a molecule. Lone pairs. Lone pairs are constant. So, for example, oxygen always has 2 lone pairs, no matter what. If it has 2 single bonds or a double bond, if it's a central atom or not, no matter what, oxygen is going to have 2 lone pairs. Nitrogen, on the other hand, is always going to have 1 lone pair. The second thing to think about are what I call bond locations. A single bond is 1 location. However, the tricky part is if we see a double bond, that counts as 1 location. Or a triple bond is also going to count as 1 location. We're thinking about central atoms. There might be 2 of them. Anything that's between some other atoms counts as central. And then we're going to use lone pairs and bond locations around that central atom to apply this table. If our central atom has 0 lone pairs and has 4 bond locations, that's going to give it the shape which we call tetrahedral. This is important. This is a shape we've never encountered before, probably in our lives. We might know about tetrahedrons, but tetrahedral shapes are a little bit different. If there's 1 lone pair and 3 bond locations, that's going to be pyramidal. It's not a pyramid, it's pyramidal. It's kind of like pyramid-ish. If we have 2 lone pairs and 2 bond locations, or also 1 lone pair and 2 bond locations, it's going to give us V-shape. If we have 0 lone pairs and 3 bond locations, that's a shape that we call trigonal, planar, not triangular, trigonal, a little bit different. If there's 0 lone pairs and 2 bond locations, or if there are only 2 atoms and there is not a central atom, we're going to end up with a linear molecule, all in a line. When we have a question that asks us to identify the shape or draw a 3D molecule, we're going to pay attention to central atoms. In the beginning, there's only going to be 1, but there might be 2, and even every once in a while, there might be 3 central atoms. Once we locate the central atoms, we're going to analyze each of them for lone pairs and the number of bond locations. Pay attention, a double or a triple counts as 1 location. Once we make that analysis, we're going to find it here on this table in order to identify the shape. And I hope that helps.